Okay, first I want to talk about the plan for the class. We have exam 3, which is not a final, it's just a test about graph theory. And I want to post it on the 6th. And I want to make the due date the 13th, but if you need time, you can work on it during finals week. And we will do review on the 11th and the 13th. And one more homework. Homework number 7. I will post this Thursday. And let's see, due on the 6th. Again, that's going to be your last homework assignment. This is your last exam, and we'll review for the exam. Cool. So for the notes, we're going to do a word problem and then some new definitions. Okay, let's find notes. Okay, a group of people meet and shake hands with each other. How many handshakes occur if, and we'll do the first part. You have 4 people. Okay, we're going to have the people represented by vertices. And a connection between the people is going to be an edge or a handshake. So handshakes are going to be the edges. Okay, so a handshake is an edge and a vertex is a person. And we have 4 people. So draw them kind of near each other like this. Okay, each person shakes the other people, like hands with all of the other people. So we connect this person with that person and that person and that person. Each time that's 1 handshake, 2 handshakes, 3 handshakes. This person has already met that person, and then they say hi here. This person meets with this person, that person, and the one on the side. And then this person has a connection to everybody. So what I want to use is a theorem. We're going to restate the theorem, but also from a picture, we can, at the end, we can check by counting. Okay, so this one. The number of edges is half of the sum of the degrees. And we're looking for a number of edges because we're looking for the number of handshakes. So let's get this degree, and each degree is going to be 3. This one's degree 3, degree 3, and again. Okay, you want the sum of the degrees. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, distracted by the cat. All right, we have the sum of the degrees, and take half of that to get the number of edges. So divide by 2, and we'll get 6 handshakes. No. I'll be right back. Is you? Okay, let's see. And what do we call this? Part 2 or part B? We have 5 people. Okay, let's draw them in a circle. This person, 1, 2, 3, 4, 5. Okay, so just pick somebody and make sure that they have a connection with each of the other people. I'll be back. We might see. We might have to close the door. Come on. You're okay. You okay? Okay, if the cat really starts crying, I might call class early, but she has a toy. She seems okay. She could be a baby sometimes. All right, let's keep on trying to work. So we've taken care of all of the connections. Here to here to here to here. This person has met with those people, but needs to meet these people. Last. Okay. Let's meet on Thursday. I'm sorry. We'll wrap up this problem. I know, she's just bored. You're okay. You're crying. You want to hang out? Okay. Okay. Let's continue. If she cries again, we'll say goodbye. Okay. Some of the degrees. So find each degree. 1, 2, 3, 4. 1, 2, 3, 4. Each is going to be a 4. Yes. Sum of the degrees out of 2, or divide by 2. So 4, 8, 12, 16, 20 over 2. So it would be like 10 handshakes. Okay, I think we're going to be okay for a bit. I hope to at least go over the new definitions today, and we'll see how far we can go. So the last part C, is just to have 6 people. Okay, and then we'll draw them next to each other like this. And then each person connects to all the other people. So just go around and get all those connections for the first person, all the way. And then you've met, and then continue across. Here, here, there, there. Okay. 4 and 5. 1, 2, 3, 4, 5. Each vertex has degree 5 in this one. Okay, so we're taking the sum of degrees divided by 2. 5, 10, 15, 20, 25, 30. So we got 15 handshakes. Have answers? Yes. Cool. Okay, so the new notes are to talk about a walk, a path, and a circuit. Okay, a walk is a sequence of vertices. Each one is connected to the other by an edge. Each connected to the next by an edge. Okay, I think I want to stay focused and just do each definition, and then we'll try examples. So first though, walk is kind of the broadest of the definitions. And then we take walk and add a rule to it to get a path. A path. Is a walk. And one more thing. It does not reuse an edge more than once. Or you could say every edge is used one time. But I'm going to go with the other one. Does not reuse an edge. Okay, and the last one is called a circuit. So there's walk, and then a path is a walk plus one more rule, and a circuit is a path with one more rule. So a circuit is a path that starts where it ends. so before we do examples, I want to just put a summary of these three definitions. So there's walk, path, circuit. A path is a walk and a circuit is a path. The walk is just some kind of sequence that actually has just each vertex goes to the next. So I just put it's like a sequence. Some sequence. And then the path is a walk and don't reuse an edge. Okay, and a circuit is a path, so you don't reuse edges, and the start is the same as the end. Okay, the first graph is just going to be a triangle. If you go A, B, C, that's a walk. If we go A, C, B, that would be a path. And then we'll do B, A, C, B, and that's going to be a circuit. And let's see, if you have a new example, it's going to be a square. This will be W, then X, Y, Z. Okay, let's do a walk. Like Y, Z, X, W, X. Let's just start there. Y to Z to X goes to W and back to X. So we start, go over and up to W and back. So we reuse this edge, which means this would be a walk. All right, let's do X, Y. So here to here, there's no connection, which means it's not a walk, which also means it won't be a path or a circuit. So not a walk. If we go W, X, Z, Y, W, that's going to be a circuit. W over 2X down to Z, across to Y, back to W. So you start where you end, and you don't reuse any of the edges more than one time. You have a circuit. Okay, and how about CXW and see what that looks like. Z over 2X over 2. Up and over. So it is a walk. Each vertex is connected to the next one by an edge. And I only use this edge one time and that edge one time. So I have a path. Okay. I feel like the cat's going to be okay. I have 3 examples I would like to do. And that's the goal for today. So the first example, we'll start drawing the graph. The vertices are A, B, C, D, E, kind of in a circle. The labels are important. So let's see. A, this will be B, C, D, E. A goes to C and D. E goes to C and D. D goes to E, A, B, and C. And that's the graph. Okay, the sequence will be D, E, D, C, A. Is this a path? So you start at D, go over to E, and then if you go back to D, you reuse that edge. In paths, you can't reuse edges. So this one's not a path. Edge DE, which is the same as ED, DE, DE, ED, DE, either way, is used more than once. EEDCA. But yeah, that's the problem. Okay. we're going to go on and ask if CADC is a circuit. Okay, let's check this out for a minute. C, over here. Let's get color. C, and go to A. Then to D, which was here. D, and then back to C. So we've made a triangle. Each vertex was connected to the other by an edge, so we got walk. We used every edge one time, so that's a path. And the place we started was C, and we end at C, so it's a circuit. Okay, we'll call this the last part for this problem. We want to do A, D, C, D, A. Is that a circuit? I'll grab some kind of color, orange, and find A. It goes A to D, over to C, back to D, and then back to A. So it is a walk, but we reuse this edge 2 times, and we use that edge 2 times, so it's not going to be a path, which means you can't have a circuit. Okay, the next graph, we've got 5 vertices. Let's get it going. Okay, A, B, C, D, E. We'll have a diamond right here, like A to B, B to C, C to D, back to A. Then we'll connect A to C, straight down the middle. And these 2 points go to E, so AE and CE. And there's my graph. Okay. I'm going to ask a question. Number 2, part A. Oh, this one's working okay. Okay, part A says, is the following a path, circuit, walk, path, circuit, or neither? So that's actually number 2, walk, path, circuit. Okay, so out of all the options, pick the best one. So if it's walk, go with walk. If it's a walk and a path, pick a path. If it's a walk plus path plus circuit, then say circuit. And if it's none of those 3, we're going to say neither. We're going with A, B, C, D, E. Okay, let's check out that sequence. Starting at A, go over to B, B goes to C, C over to D. Okay, there's a problem. We can't go from D to E, or there's no edge from D to E. So this is not a walk. Which means it's not a path or a circuit. So we're going to say neither. All right, the next one is A, B, C, D, A. A goes to B, which goes to C, and that goes to D, that goes to A. Okay, let's find vertex A, and then go to B, over to C, okay, then D, back to A. So it was a walk. We went from each vertex to the other one using an edge. It's also a path. This edge is used once, same here, and there. And you start where you end. So we have a circuit. Let's do one more. We're going to do 2 more. Okay, part C is going to be short. CE. C over to E is a walk. And it is also a path because that edge is used one time, but you don't end where you start. So we can't say circuit, but we do choose path. Okay, so this will be the last part. It goes A, B, C, A, let's see, A, B, C, A, D, C, E, A. Again, it goes A, B, C, A, D, C, E, A. let's check it out. Starting at A, go over to B, and then C, back to A, over to D, then to C, reach to E, back to A. So we end where we start. It also was a walk. We got to go to every vertex using an edge. And we used each edge one time. So it's a circuit. I'm going to clean it up and just talk about it one more time to check that we got that. So we went A, B, C, A, D, C, E, A, which was a walk and also a path and a circuit, so we choose circuit. Okay, I want to do one more, and that's good for now. So number 3, we're going to get the graph. So let's start with a square. And a vertex on every corner. We'll have a diagonal line through here. Let's get some labels. C, F, E, B. And put a vertex right there called D. And right here is called A. And connect A to B. That's the graph. And it should be the same question. Is it a walk, path, circuit, or neither? Number 3, part A. We're going to go from A, B, D, E, A. Okay, so I have an A at the beginning and the end. So it could be a circuit, but I need to check that we don't reuse any edges. So it has to be a path and the end has to be the same as the start. So let's go from A to B. B goes to D. D goes to E. E goes to A. Okay, so it was a walk, check. It is a path. We used each edge one time. And we start at A and end at A. Makes this a circuit. Okay, part B. It's going to be A, B, C, D, E, F. So we've got a sequence. If each vertex is connected to the other by an edge, it will be a walk. If we don't reuse edges, then it's a path. And if it starts where it ends, it's a circuit, but we're going to start at A and F. F is the end, so it's not a circuit. What is it though? Let's check it out. A goes to B. B goes to C. C goes to, it says C goes to D, but we don't have an edge between C and D, so this is a problem. It's not a walk. And if it's not a walk, then it's not a path or a circuit, so we're going to say neither. And this is the last one. It goes A, B, C, A, B, C, A. C. And again, A goes to B. C, A. So it might be a circuit. There's an A at the beginning and an A at the end, but I can't reuse edges. So let's go to A, and then over to B, and then to C. Then it goes back to A, and to B, and to C, and to A. So you travel around that triangle 2 times, which means you use that edge twice, and that edge twice, and that edge twice. So it's not a path, but it is a walk. Because every vertex was connected to the next one by an edge. Okay, so we're going to continue to practice paths and walks next time. Thank you for being patient with me and my cat. And I'm not going to post new homework till Thursday.